Welcome to Maths with EJD. In this video, we'll be talking about addition and subtraction of complex numbers, second video on complex numbers. And here we'll be looking at the introduction, some geometric interpretation, some demonstration of addition and subtraction of complex numbers, and then we'll reach a simple conclusion. So straight to it, the idea of addition and subtraction of complex numbers is very straightforward, because all it requires is to add or subtract complex numbers a plus bi and c plus di. Simply add or subtract their real and add or subtract their real and imaginary parts separately. So what that means is that you add a to c and you add b to d with the I attached. That's all. So it's pretty simple. And if you're subtracting, you are going to say a minus c and then b minus d with attached with the I. So simply for addition, you have a plus bi plus c plus di. So a and c will have to be together because they are the real parts. And then b and d will be together because they are the imaginary parts. So that at the end of the day, you have a plus c plus b plus d all into I, like that. So a plus c separately plus b plus di, because b and d are the imaginary parts and a and c are the real parts. So same for subtraction, right? You have a plus bi minus c plus di. That means you have a minus c here plus b minus d right here. So you have a minus c plus b minus d I. Okay. So in this case, right, talking about the geometric interpretation, it's basically this, that complex numbers can be represented geometrically on the complex plane. So there's something called the complex plane. You know, in the real, when we talk about the real number system, right, you have the x-axis and the y-axis. So, but in the complex plane, it's something close to this, except that the x-axis is the real part and the y-axis is the imaginary part, as you're going to see very soon. Okay. So talking about addition now, vector addition on the complex plane. So you can do vector addition on the complex plane, and you can also do vector subtraction on the complex plane, as you're going to see pretty soon. So this is a very good representation of the complex plane. So you see that this particular point, right, is z equals a plus bi. So that's a on the real. So you can see the x-axis is the real axis and the y-axis is the imaginary axis. So on the real axis, you have a. So you have a here. And then on the imaginary axis, you have b. So if, for instance, z equals a plus bi, so you locate a here, you trace it up, and you locate b here, you trace it wherever they intersect, like normally when you're plotting. So that particular point, right, is the z equals a plus bi. So that blue point is your z equals a plus bi. But the line itself, this line itself, is the vector. Okay, so it's line from the origin to that point z. So this is point z now, but then you have a line drawn to that point. So that's how you do it. I mean, to drive this home, right? Let's see. To drive this home, let's see what we can do. So let's take some examples so that this can be well clarified. So for the demonstration, now let's consider two complex numbers. You have z1 equals 2 plus 3i and z2 equals 1 minus 2i. So z1 plus z2 will simply be 2 plus 3i plus 1 minus 2i. All right. So add the real parts together. That's 2 plus 1. That's what you have here. Add the imaginary parts together. You have 2 plus minus 2. No, I mean 3 plus minus 2. That's the same thing as 3. Plus times minus is minus 2. So that's why you have 3 minus 2 here. So at the end of the day, you have 2 plus 1, 3. 3 minus 2, 1. So that's like 1i. 1i is simply I, right? So that's why you have, for the addition, you have 3 plus I. So when you come to subtraction, right? So for the subtraction, you have z1 minus z2. So 2 plus 3i minus 1 minus 2i. Okay, so that means you have 2 minus 1 as you have here, and then 3 minus minus 2. So 3 minus minus 2 equals 3 plus 2. And that's why you have 3 plus 2 here. So 2 minus 1 is 1. 3 plus 2 is 5. So z1 minus z2 is actually 1 plus 5 I. 1 plus 5i. So that said, you can see the representation of all this on the on the complex plane, rather, on the complex plane. So you have the real axis, and you have the real axis this way, and you have the vertical axis that way. So, and what does that tell us? So Z1 equals 2 plus 3i. So 2 plus 3i, so come to 2 here. So you have 2 on the real, 2 this way, and 3 this way, and they meet around here. So that is point 2 plus 3i. So this is point 2 plus 3i. So draw a line from the origin to meet that. That is your 2 plus 3i. Then for 1 minus 2i, right? 1 minus 2i, that's 1 on this axis, then minus 2 on this axis. So this point now is so this is actually point 1. This is point 1 minus 2i, all right? And then you draw a line from the origin to meet that point. That is how to represent that one. Then Z1 plus Z2 is actually 3 plus I, right? That is 3 on the real axis. So come to 3, trace it up, and then 1 on the horizontal, on the imaginary axis. So trace this. So where they meet, somewhere around here, that is this is your point Z1 plus Z2. Then you draw a line from the origin to meet that. And that is the representation of Z1 plus Z2. Plus for Z1 minus Z2, right? That's 1 plus 5i. So come to 1 along this axis and 5 along this other axis. So this point, right, is where they meet. So you have 1 plus 5i actually there. And then from the origin, this is origin 0. So from the origin, you draw a line up there. And that is your Z1 minus Z2. So that's the simple representation, So it's just like what you have in the Cartesian coordinate system, where you have x and y axis, except that the x-axis here is the real part, and the y-axis is the imaginary part. Okay. So, straight to the point. In conclusion, addition and subtraction of complex numbers are straightforward, very straightforward, as you can already see. So they are straightforward. So geometrically, addition is like vector addition, and subtraction is like vector subtraction. On the complex plane, and now you've seen what the complex plane looks like. You have this, and then this is real, and this is imaginary. So that if you want to represent minus 2 plus 3, okay, let's say minus 2 plus 2i, right? So this is minus 2 on the real axis. So let's say this is minus 1, this is minus 2. So you have minus 2 like that. Let's say you have minus 2 all this way. And then on the other part, you have the real part, which is 2 on the vertical axis. So let's say this is 1 and this is 2. So you have this line going. So this is actually point minus 2 plus 2i. So if you now draw a line from the origin to meet that point, so that is how you represent minus 2 plus 2i in the complex plane. So that's how it goes. So be sure to subscribe to this channel, hit the notification bell so you can get all the videos that will come. After this, I'll be talking about multiplication and division of complex numbers. Stay tuned. See you in the next video.